Welcome all in class 12 on PCB design course. In this class, we will discuss about the complete process for printing the PCB. The first step in printing the PCB is designing of the circuit. Second step is creating the proper schematic diagram using some computer aided design tool. Third step is defining PCB design rules. Fourth step is board layout designing using CAD tool. Fifth step is printing the PCB, and the sixth step is insert drill holes to mount components on the PCB. So for designing of the circuit, the very first thing that we should know is we must have the clear understanding about the circuit for which we want to design the PCB. We must also have understanding about the specifications and package details of the components that we are going to use. We must be aware about the electrical parameters of the circuit. In electrical parameters of the circuit, we must aware about the current, voltage and power in various parts of the circuit, signal types on PCB, that is whether it is digital or analog signal that we are going to use, the operating frequency of the circuit, the impedance characteristics of the circuit elements. The second step in PCB printing is creating the proper schematic diagram of the circuit. The schematic diagram primarily consists of the component symbols and the lines that represents the connections between the components for a particular circuit. The electronic computer aided design tool are used to develop a schematic with a software platform. The schematic diagram of a circuit using a computer aided design tool is as shown in the slide. Next step in printing the PCB is defining the PCB design rules. A design rule check is a set of rules used by a designer or manufacturer of PCB to ensure that the schematic matches all the manufacturing considerations and dimensional tolerances set for a board. This step is largely dictated by the standards and acceptability criteria from IPC. Some examples of DRC in the design includes the spacing between the traces. This is the minimum gap between two traces. The spacing between the trace and the adjacent pad. This is the minimum gap between a trace and an adjacent pad. The spacing between adjacent pads. This is the minimum gap between a pad and an adjacent pad. The spacing between the traces and adjacent via. This is the minimum gap between a trace and an adjacent via. The spacing between the pad and adjacent via. This is the minimum gap between a pad and an adjacent via. The spacing between adjacent vias. This is the minimum gap between a via and an adjacent via. The spacing between edges of copper and edge of PCB. This is the minimum gap between the edge of copper and the edge of your PCB. This edge of PCB could be the outer parameter of your PCB or a cutout route inside the PCB itself. The spacing between edges of holes. This is the minimum gap between the edges of one hole to the edge of another hole. The hole could be plated or non-plated, but the rules are same for both. Minimum trace width. This is the minimum width of trace can be. Minimum drill hole diameter. This is minimum diameter of a drill or hole. The last but not the least parameter that we can check in DRC is separate ground connections for analog and digital signals. So these were some of the check rules that can be incorporated into the schematic diagram using DRC tool in computer aided design tool. Now these rules are subject to the dictation by the manufacturer or fabricator of PCB. The next step in PCB printing is board layout design using CAD tool. So next in the series is the placement of components and connecting the components with the best route on board as per design rules. That is, once we have made the schematic diagram, then after checking the design rules, the next step is the placement of components and connecting the components with the best route on board as per design rules. A board layout which represents the components and connection between components is obtained by using electronics computer aided design tool. On board layout, components are represented by their footprints. So next step is printing the PCB. So in order to fabricate PCB at workplace, we can get printout of PCB board layout designed using CAD tool on a photoglossy paper using laser printer. Next, we have to print the board layout on copper board. So in order to print the layout on board, we place the glossy paper onto the copper board. The heat from the iron transfers the ink printed on the glossy paper to the copper plate. After ironing, place the printed plate in lukewarm water for about 10 minutes. The paper will dissolve and can be removed from PCB. In some cases, when removing the paper, some of the tracks gets fainted. So we can use a black marker to darken these tracks. Next step is to remove unwanted copper from board. This can be achieved by using etching process. So in order to start etching, first put on rubber or plastic glove to start etching. We will use ferric chloride solution for purpose of etching. Dissolve 2 to 3 teaspoons of ferric chloride powder in water and dip the PCB into the etching solution for approximately 30 minutes. After etching process, the excess copper will be removed from the board. A few drops of thinner, maybe nail polish remover, on a pinch of cotton wool will remove completely the toner ink on the plate, exposing the copper surface. So up to now we have printed the circuit on a copper copper plate. So next step, because we want to put components onto this board. So next step is we have to insert drill holes into this PCB. So next in series is to insert the drill holes on the board so as to mount components on the board. Drill on the board are guided by the design for manufacturing specifications of your PCB manufacturer. The mass level production of PCB can be obtained by using screen printing method. So screen printing method can be used to print circuit on PCB for mass level printing of PCB. The Gerber files for the PCB to be designed are required by PCB manufacturer to finally print the PCB at large scale. The Gerber files for the circuit are generated from the board layout of PCB, which has been designed by some CAD tool. So this was the complete process for printing the PCB that we want to discuss in this class. So this is all that we want to discuss in this class. Thank you.